The inverting amplifier. Before we start the analysis of an inverting amplifier, let's go over the three basic rules of amplifier analysis. So number one, the gain is huge. The output is going to swing in the direction of the input that is greatest. So if the positive input is greater, the output swings up. If the negative input is greater, the output wants to swing down. Number two, the inputs of an op-amp are high impedance. No current flows into them. So that means that the input of the op-amp is essentially an open circuit. And number three, with negative feedback, the op-amp will adjust the outputs until the inputs are equal. And by equal in this case, since this terminal is tied continuously to 0 volts, the op-amp will be stable when this input is also 0 volts. So let's imagine we're putting a sine wave on the input of the op-amp, but let's freeze it at this point in time right here with 1 volt here, and let's see what happens. Now 1 volt on the negative input is going to be greater than 0 volts on the positive input, so current is going to flow into the op-amp circuit. It's going to flow from 1 volt on this side of R1 to 0 volts on this side of R1, and that's going to create an input current. That current cannot flow. That current cannot flow into the input of the op-amp, so it's got to go around. So that current is going to go around the input, and it's going to flow through the feedback resistor, and then it's going to flow into the output of the op-amp, and it's going to flow into the output of the op-amp because the op-amp output is swinging towards the negative supply. We put in a positive voltage on the negative terminal, which means the output swings down, and that allows the current to go around the op-amp and through the feedback resistor. This creates a voltage drop across the feedback resistor. And that voltage drop is a function of the current, which happens to be the input current, which is also equal to the current through the feedback resistor. And that's going to create a voltage drop across the feedback resistor. So VRF is going to be equal to IRF times RF. Now the other thing that you need to note is that VRF, which is the voltage across this resistor, well, that's also going to be equal to the output voltage. And why is that? Well, because over here on this side is tied to 0 volts, because it needs to be the same as this voltage. So there's a virtual short between these 2 points here on the input. So if this is 0 and you have a stable operating point, this is also 0. That means that this voltage here is going to be, V out is going to be equal to IRF times RF. Well, we said that IRF, well, that current over here, that current, IRF, comes from the input. That's what goes around. So IRF is also equal to IN. So V out equals IN times RF. But IN is VN over RN. We got IN. That came from applying the input voltage here on one end of this resistor and the other end is ground. So IN is 1 volt over R1, or VN over R1. So V out equals VN times RF. Now what we want to do is we want to take this thing here and we want to drag it over there like so. We end up with V out over VN is equal to RF over RN, and it's going to be minus RF if you take a look at the polarities. And what is V out over VN? That's another way of saying AV. So that is how you calculate the gain on an inverting amplifier. Zin on the inverting amplifier, well, let's take a look. This is the source here, and it's applying its 1 volt of voltage to this circuit here And this end of the resistor, this is 0. So basically, Zin is the impedance looking into this circuit. And if I look into this circuit here, basically between the input here and ground is just this resistor. So Zin in an inverting amplifier is basically Rin, and in this particular circuit, R1. What about Z out? Well, let's just get rid of a few things here. Clear off our output here. We had figured out that the gain of this circuit, we had figured out that AV equals minus RF over Rin. Let's make this 10K, make this 1K. That means gain is minus 10 over 1, minus 10. If I put 1 volt here, that means that there is minus 10 volts on the output. So if I put a 1 k ohm resistor down here, if I put 1 volt here, there'll be minus 10 on that resistor. And if I put 100 ohms on the output here, you would still get minus 10 volts. Because with negative feedback, the op-amp will adjust the output until the inputs are equal. If the output deviates from minus 10 volts, then this point is no longer 0, and it will make a correction to get it back to 0. So it's going to hold the output at minus 10 regardless of what you stick on here. Now, if you have a voltage source that is minus 10 volts with an internal impedance, here's my 10K, here's an internal impedance, RS equals question mark. If no matter what I stick on this source here, if no matter what I stick on this source, it always sits at minus 10 volts, how much is RS? The answer to that is simple. It's 0 ohms. When you use feedback to amplify a circuit, because the op-amp will adjust the output until the inputs are equal, if you change the load, it will compensate for that to get the voltage back to the same value. This effectively makes the Z out of an op-amp circuit 0 ohms. In reality, it's not exactly 0, but it's very, very small. Note this is also when you have feedback. Now, that doesn't mean that the op-amp can drive anything. Obviously, these little op-amp packages have a current limit that they can source only so much current, but until you hit that current limit, you will basically control the output at the desired value and have an effective Z out of 0 ohms. Let's summarize the inverting amplifier. So number 1, when the input goes up, it's going to the negative input, the output goes down. That means that the gain is negative. Current, though it flows into the input, goes through the feedback resistor, creating a voltage drop across the feedback resistor, and that is the output voltage, which is proportional to these two resistances. So the gain of an inverting amplifier is minus RF over the input resistor. When the op-amp is working, it's adjusting the output until both inputs are 0, which means that basically, as far as this signal is concerned, it has this resistor on it. Zin is equal to Rin. The op-amp will adjust the output until the inputs are equal, and it will continue to do this. So it doesn't matter what you stick on this, 1 k ohm, 100 ohm, 10 ohms, it will bump the voltage back up. So Z out is approximately 0 ohms. While we're talking about inverting amplifiers, let's talk about the summing amp. Now, the summing amp is a class of inverting amplifiers with multiple inputs. So you can see in this example here that both of the inputs are going to the inverting input. So this is an inverting amplifier. Now remember the rules. We said that with negative feedback, the op-amp of the output will adjust until the inputs are equal. And again, in this case, Equal means 0 volts. The positive terminal is tied to 0, so this op amp will stabilize when this point is 0 volts. So what's going to happen is no matter what V1 and V2 is, current is going to flow into the circuit. So we'll call this I1 and we'll call this I2. And they're going to join together. This current is going to merge together into this node. And essentially what is going to come out of here is going to be the sum of I1 and I2. And that's what's going to go through RF. So VRF is going to be equal to I1 plus I2 times RF. This is going to make the output on this circuit here. When we look at this output, Vout is going to be equal to minus RF over R1 times V1 plus minus RF over R2 times V2. So the summing amplifier is going to amplify each input independently and add them together into one final output. The summing amplifier is how karaoke machines work. You've got the music track going into one input, and then you pick up your microphone, and as the dancing dot goes along the top of the words, you basically sing into the microphone here, and that goes into the second input. And basically what the summing amplifier does is it will mix the two of them together, and it will put your voice on top of the music so you're singing along with the song.